In this, we're going to skip ahead to section 6 because it's more graphing. So this is going to keep the two graphing sections next to each other in terms of when you learn them. So section 6 is systems of linear inequalities. To determine if something is a solution, it's the same process as when we had equations, where you're just going to have an ordered pair that works or satisfies each inequality. And so if we want to check on our first example, we have our system of linear inequalities. These are inequalities because they have less thans and greater thans. I have two different ordered pairs to check. So checking one at a time, letter A, I'm going to substitute in the x and the y. So 3 times 3 plus 4, is that less than or equal to 9? And so I get 9 plus 4, which is 13. Which is obviously not less than or equal to 9. Therefore, this ordered pair is not a solution. Part B, I have the ordered pair 2, 1, so I put in the 2 and the 1, and I get 6 plus 1, which is 7, which is indeed less than or equal to 9. And then I go to the next equation and I try the 2, 1 in there to make sure that it works. So we have 10 minus 3, which is 7, which is indeed greater than or equal to 2. So that means that the ordered pair 2, 1 is a solution. When we want to find our own solution for a system of linear inequalities, it's going to involve graphing. So what we're going to do when we graph is we're going to graph each inequality, treat it like an equation, and since we are graphing inequalities, we will sometimes use solid lines. Using a solid line when we have the or equal to underneath our inequality. And we're going to use a dashed line if it's a strict inequality, which means it's just a less than or a greater than. And then we're going to pick a test point, which is any point that's not on the line that we just drew. And we're going to do that for each inequality because we're going to have 2 of them that we're graphing at the same time. Or we could have more. I think we'll just stick with 2 though. And we put that test point into the inequality. We see if it's true or false. And we shade, it's called the half plane, which is just the side of the line where it's true. And finally, our answer is going to be the shaded region that's overlapping. So our answer is not just like a single ordered pair. Our answer is the picture of the graph showing where the shading overlaps. So we're going to graph. These are both slope-intercept forms. We have a slope of 2 over 1 and a y-intercept of 0, -3. And here we have a slope of -3 over 1 and a y-intercept of 0, 1. So I'm going to go ahead and graph those. This is section 4.6, example 2, part A. And we draw so I have an intercept at -3 up 2 over 1 using a solid line. Oops, and before I go on and draw in the next line, I'm going to look at my shading. I get to pick whatever test point I want. Since my line does not go through 0, 0, I'm going to go ahead and pick 0, 0 because that's easiest. So when I put in a 0 for the x and the y, I want to know, is this true or not? And it is true. Since it's true, we're going to shade the side with the ordered pair 0, 0. And so from this line, that means that we're shading kind of the top left area. So all of that would be shaded in. When you're working your homework on MyLabs, you get your line, and there's different buttons you can click to get solid lines versus dashed lines. And then there's also different buttons you can click for your shading, or maybe it's a little paint can fill where you click where you want it to be shaded. When we graph our other line, slope is -3 over 1. Solid line again because it's got the or equal to. And I have to test in this line. I'm going to use 0, 0 again because it's easiest. So I get 0 less than or equal to 1, that's true. So that was off of this line here, which means I'm shading towards the 0. My answer is the section where the shading overlapped. So I'm going to kind of darken that in. It's this wedge area to the left. So my solution is any point over here. What that means is I could pick any ordered pair in this region, whether it be this point here, this one up here, over here, and here. Any ordered pair in the shaded region, when you substitute that into the equation, into the inequality, it'll work. It'll be true. All right, graphing, so what do we have? Part B. So when I graph part B, I'm going to rearrange this one because I don't want to graph a fraction. If I tried standard form, I'd end up having to graph a fraction. So when I graph this one, I get a y-intercept of 7 with a slope of 2. And this one, I get, this is a little harder, so if I tried for intercepts, they'd both be 0. So I need something a little more than that, so I'm going to rearrange it. I'm going to add 3x and then divide by 2. So there's my 7 down 2 over 1. Dashed line. And then the other line goes through 0, has a slope of up 3 over 2. It is also a dashed line. For my test point, I can use 0, 0 for this line. And when I put that in, I have 0 is greater than 7. That's false. So that means this line is shaded above because that's where the 0 is not. And this line, I can't test 0, 0 because the line goes through 0, 0. So I'm going to test 1, 0, just picking a different point. So I get, when I put in the 1, I get 3/2, so that's also false. So on this line, 1, 0 is right here. It's false, so I do not want to shade it, so I shade up here. So the overlapping region is this top part right there. And one more quick example. We're looking at a horizontal line and a vertical line. And so if I graph that vertical line at -3 on the x-axis, it's a solid, and it's greater than, so it's shaded this way. 1, 2, 3, 4. So here's 5. This one's a dashed line. It's less than, so it's shaded below. So this part right here is our answer.